Okay, Ansh, thanks for the second email. We are going to start going over the second set of questions that you have sent for me. Yeah, for today, when we did the lesson at C2, we didn't have enough time to quite frankly go over all these questions. Okay, so I took taken a look at all the questions, and yes, we're definitely going to be talking about the standard deviation and what it means in the SATs. So let's go over this first question with the circle here. Okay, so I'm just going to write on top of this. This is actually a very quite simple problem. In the circle above, segment AB is a diameter. So right here, this, oh shoot, um, this is going to be a diameter right here. So what you're going to do then is you're going to take a look at ADB is 8 pi. Well, ADB, this right here, you wrote it as also 8 pi. Okay? So because that we say that this is a diameter, this actually basically cuts this circle into half. So if this is 8 pi, then this is also going to be 8 pi. So another way of thinking of it is that this angle that is going to create what we call the central angle, that's going to be 180 degrees. And vice versa, that's also going to be 180 degrees, which creates a total of 360. So it's 8 pi, and that's a total circumference of 16 pi. Now, what we're interested in is solving for the radius of the circle. So if the circumference, you know this formula, should know the formula, it's 2 pi r is equal to 16 pi. And then so if you solve for the radius, it should just be 8. Now, this is a really, really simple problem, okay? If you ever wonder about, let's say you have a circle, and then you don't have just imagine for a second at the center, and you want to know, the arc length of, let's say, from A to B, only this portion, and you basically have, let's say, the theta, which is given to you as, let's say, I don't know, 70 degrees, and they tell you that the radius is 10. So then they will probably ask you to find the arc length AB. In that case, you will use the formula for the arc length, which is theta over 360 times 2 pi r. And by plugging in the numbers, like so, you will get to the answer right away. So this right here is what's important. And because for this problem here specifically, the central angle is what we would call like 180 degrees. So if you plug it in, it's just going to be simply 1/2. This part right here is going to be 1/2 of the circle. So its circumference is 16 pi. Okay? All right, so that one was very easy. I'm going to put the standard deviation question for the last one, and let's do question number 30. Now, for this question, whenever I was doing this with a student, I always tell them that this is really not like a math question. It's more like a drawing kind of question where so say let's just jump in right into the problem. You have the graph of this fancy polynomial, which we're really not going to consider anything for. It's graphed in the xy plane above. If k is a constant such that equation f of x equal to k, let's focus on that. F of x is equal to k. Now f of x is saying nothing more than just like let's say y, and k is a constant value. So for example, if I'm going to take a look at the answer choice A here, and we're saying the k value is 2. So imagine for a second that I have y is equal to 2. So I'm just going to be moving this. Okay? So if y is equal to 2, then the line of y equal to 2 will look like this. That's y is equal to 2. So if y is equal to 2, there is one intersection point that it makes with this fancy curve right here. So that will basically create one real solution. When they say a solution in a system, it means an intersection point. And as you can see, for answer choice A, it's not going to work. Why? Because I only have one solution. There's only one intersection point. For 0, let's draw a line at 0. Again, one intersection point. C at -2. It might kind of be close to be touching with this portion right here, but it's really not. So there's only really one intersection point right there. And so the final answer, which is D, that is going to be the right answer because, look at that. 1, 2, and 3 with the blue curve right there, right? It goes through 3 times. So what that real solution means, the solution means intersection points when we're talking about systems of any equations here. Okay? All right. Let's move on. Compared to the last time, these questions are actually quite easier to do. Okay, so for this, I'm going to assume that you need help for both 25 and 26. So let's do this one first. Okay, so let's take a look at the problem number 26 first. Okay, so 26 says let x and y be such a number, be such numbers that negative y is less than x and less than y. So if you just focus on that inequalities right away, you should probably say, even before just plugging in these random numbers that you did, which was negative 5, 2, and 5, which is good. So you used y as 5, right? That's great. But think about what happens when y equals negative 5. Can that work? Absolutely not. Why? Because take a look at here. If you plug into negative 5 into here, that makes it positive 5x and less than negative 5. This makes absolutely no sense. How can negative number be on the highest end, right? So what that shows you is that y must be any positive number. It cannot be any negative number. So that makes Roman numeral 3 to be true. Now, the thing about Roman numeral questions is that if you know absolutely for a fact that this gotta be true, you could definitely eliminate A and B. Because Roman numeral 3 has to be part of your answer choice, right? So now we're going to go to Roman numeral 1 or Roman numeral 2 and then just verify which one is going to make sense. So let's check for Roman numeral 2 here. So I'm just going to erase all this. Okay. Let's check for Roman numeral 2. So because if Roman numeral 2 is correct, if this is supposed to be true, then D is the only answer that I'm going to get because C doesn't contain Roman numeral 2, right? So let's check for Roman numeral 2 here. Now, let's use the example that you had before. If you use, let's say, for example, 5, then x is anywhere between negative 5 and 5. So what are some numbers that fits in what are some numbers that fits in x? Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4, right? Look at all these negative numbers that are potentially possible to be the value of x. And 2 is only saying that x has got to be bigger than 0, right? Which makes no sense because we just proved it, right? That x could be negative. So therefore, C is going to be out because you cannot contain 2. So it's going to be answer choice C. Now, just for the sake of going over the question, I am going to show you why Roman numeral 1 is going to make sense. So Roman numeral 1 says, absolute value of x is less than y. Well, absolute value of x means no matter what I did, so for this problem, remember, negative 4, negative 3, negative 1, 0, 1, 2, 3, 4, any number that you decide to select and you plug it into the x, because you take an absolute value, it's going to give you a positive number, right? Well, because y is something that is bigger, take a look at this, the y is bigger than x, right? Because of that, it's always going to yield something that is going to be less than y if x turns out to be positive. So we're only taking a look at these answers, right? And in lo and behold, all of these answers are going to be less than 5. And so you can use your example that you use to your advantage to actually help you solve this problem. Okay? All right, so that one's done. Now let's take a look at 25 here. Well, now 25 says the polynomial f of x and g of x is defined above, which is the following polynomial is divisible by 2x plus 3. Okay, so here you basically have this and you manage to factor it out. And then you have this, I'm assuming that this is your f of x, and I'm assuming this is your g of x. Okay, now what I think you should probably notice is that g of x kind of repeats itself. So this is your g of x, but that same thing happens in your f of x. So what we're interested in is this part, divisible by 2x plus 3. If I were to take, let's say, answer choice A, we have f of x plus g of x. But what we do know is that f of x is same thing as saying 2x times another g of x, right? So this I can rewrite it as 2x times g of x plus g of x. And by factoring out a g of x from both sides like this, in the parentheses, I'll get 2x plus 1. So in this case, for answer choice A, you would say that that is divisible by g of x times 2x plus 1. Because if you were to take this, you would say divisible by 2x plus 1. Because if you take this function and divide by 2x plus 1, look at what happens. They cancel out. So this is not going to be the answer choice that I'm looking for because I want to look for plus 3. So in order to make this as plus 3, it makes sense that there's got to be a 3 in front of this, right? That makes a 3 in front of this. So what answer choice am I looking at? I'm looking at answer choice B. Look at that. F of x plus 3 g of x. If you use the same rule and calling it f of x as 2x times g of x plus 3g of x, and you manage to factor g of x out, then lo and behold, you will have 2x plus 3 times g of x, in which you can factor out, and so you would be able to divide that by 2x plus 3 because then it will just cancel out. Make sense? Okay. That was a pretty tricky problem, but it's nothing more than just factoring. All right, so that page is done. Okay, let's take a look at this. Now, I'm pretty sure for this one, what a lot of kids were able to do was that they were able to eliminate, I think, A and, oh shoot. They were able to eliminate A and B. So the reason is, we are looking for what does number 61, this thing, represent in this equation, right? Well, you know, every single time I give you something like this is a linear interpretation question. They're asking you what this or this might represent. Now, y equals mx plus b. M is your slope, b is your y-intercept, and I always said slope is the rate. How fast, rise over run, how fast is this population density and in relation to relative housing costs increasing or decreasing? Y-intercept is what I like to call the initial value. So that's basically when your population density, which your x, is turned out to be a 0. So that's what 61 means. It means that when your population density is somewhere close to being 0, right? Population density somewhere close to being 0, then you're gonna be getting somewhere like here, which is around 51-ish. Okay, so it's kind of hard to write it if I zoomed out. Here, the reason why we don't want to say it's the lowest housing cost in the United States was about $61 per month, or the lowest housing cost. This is talking about dollars per month. This is a percent of national average cost, so that just doesn't coincide with what the y-axis is talking about. And B says in 2005, the lowest housing cost in the United States was about 61% of the highest housing cost. Well, actually, this one I think I should kind of erase it. B could potentially be the answer, but I gotta read more. Okay, so let's go to C. In 2005, in cities with low population densities, housing costs were never below 61% of the national average. And D says in 2005, even in cities with the low population densities, housing costs were likely at least 61% of the national average. Okay, so I'm going to explain to you why D is the most appropriate answer for this one because of this word right here, likely. When you take the statistics in the real world, because this is statistics, right? And if you say B, for example, the lowest housing cost in the United States was about 61% of the housing cost, okay? You do not know that for sure, okay? The lowest housing cost, we're saying basically, what if I get a data point that's somewhere around here? You know, if it was probably like around, I don't know, 30% of the national average cost, you could potentially have a data set that represents that, right? This is just saying straight up the lowest housing cost was about 61%. No, you don't know that for sure. It might be close to it. If you say the word likely, right? If you said the word likely that it's going to be occurring, then it might be okay. But if you just bluntly say that it's going to be the lowest, well, who knows? There might be some housing that are maybe lower than 61%. You never know that. And same thing with C. The word here is the word never. Just like this one that I've drawn for you right here. Okay? You could potentially have a data set that could be below 61%. Who's to say that it's going to be never below 61%? So D has this word likely. Even with the low population and densities, housing costs were going to be as likely that it's going to be around or at least 61% of the national average. This is the statistics term that we all love and like. We do a study in the real world. We gather the data. Then when we make a conclusions based on the data, we always want to say, oh, based on this statistics, it's going to likely that this is going to behave in certain ways, or it's going to be unlikely. Okay, so the word likely and unlikely. Key word in doing statistics, okay? Whenever there's talking about a question like this, please note those words as essential key tools, okay? All right, so let's move on. There are a lot of data statistics questions in this one. let's see. Okay, so this one here, I'm assuming that you need help with both of these guys as well. So the pes, a Roman measure of length is approximately equal to 11.65 inches. It is equivalent to 16 smaller Roman units called digits. Based on these relationships, 75 Roman digits is equivalent to how many feet? Okay, so your ratio right here, oh shoot, I did it again. Okay. So your ratio right here is actually good. So you have one pace, and then that's 11.65. I really don't think you should be able to just write that. I think you can just have 11.65 inches simply means that it's 16 smaller Roman units called the digits, right? Based on these relationships, 75 Roman digits. So when you're doing this, I think what you should do is you should actually take the ratio to be 11.65, right, over 16 is equal to, I'm just going to kind of overwrite this, x over 75. So I don't know if you can see this. Take this and try to see if you can, yeah, I think that's better. You can see that now, right? Okay, so it's 11.65 over 16 is equal to x over 75 because that's how many inches that would be. This is how many digits. That's how many inches that will be, and that's how many digits. Now afterwards, please don't forget that you're going to have to take this and convert it into feet. This is what you did here, but you have to divide by 12, right? Cross multiply it this way and then divide by 12, and you should be able to get the right answer. I'm just going to do that in the calculator real quick. So what I did was I did 11.65 times 11.65 times 75, and then you divide that by 16. So I get 54.609. Okay, so it seems like I got exactly the same thing as you did, and then you divide that by 12, right? So I get 4.55. How many feet to the nearest hundredth? Oh no. Okay, so you did everything correctly here. But the reason why it's not going to be 5 inches is because look, it says 100th. 100th means this place right here. 10th, and this is 100th. So this is actually, it's going to be 4.55. That's going to be your answer. Okay, so always make sure that you read it correctly. Okay, so now let's take a look at 34. Now question 34 is actually pretty good to do. Now in this question, in a study of bat migration habits, 240 male bats and 160 female bats have been tagged. If 100 more female bats are tagged, how many more male bats must be tagged so that 3/5 is the total number? So you said 3/5 is equal to something like 500 something. Well, currently 240 male bats, 160 female bats, that's 400, and the 100 more female bats means plus 100, so that does indeed equal 500. Now here's something that you're forgetting. How many more male bats, right? And how many, we don't know what it is. So the more male bats, I'm going to call it X. So you're going to add an additional X amount of more bats on top of that. And so 3/5 is the total number of the bats in the study are male. Well, how many current male do I have? 240. Plus this as well, because that's how many total male bats. Well, X is also the number of male bats, so then we can put them together. So this top number represents male bats in total. This represents total number of female and male bats. So this is the ratio you want to set up. Cross multiply simply, and you get, let's see, 1500 plus 3x is equal to, what is that going to give you? 1200 plus 5x, and if you move everything around, I think you get 300 is equal to 2x, so x would be 150. Let me know if that's correct. I'm sure I did everything correctly there. So that is the ratio you set up. Cross multiply, solve for x. That's all you got to do. Okay, so that's done. And let's see. So we started the standard deviation problem. We have 2 more to go. Actually 3 in total. Let's take a look at this. So this seems pretty simple enough. It says which of the following function equivalent form of the function f, which the minimum value of f appears as a constant or coefficient. So minimum value, and this is a quadratic. And in quadratic setting, you either have a open up parabola, open down parabola. These two are what we call the vertexes, the vertex or the vertex maximum or minimum value. Now, which of the following has that value appearing? you must know your vertex form. The special characteristic of a vertex form is that it has something squared in it. Okay? This you need to memorize. And h comma k is going to be always your center. Okay? And a just kind of tells you like how dilated it is. So it's like how skinny it is or how wide this parabola is. That's what a is all about. But we're really not focused on that right now. We're really focused on getting my vertex point. Now, yes, by knowing this, you can definitely eliminate a and b because it doesn't look anything like that. Look at that. Answer choice C and D looks like what we call a vertex format. I see something squared. So then what am I going to do? I am going to take a look at these zeros, which is at -6, and x equals +4. Now remember, in a quadratic, if the 0 is at 4 and another 0 is at -6, a vertex happens in the middle, exactly in the middle of those two x values. So the middle value of these two simply, it's like finding the average of those two values, which is going to give you -1. So at -1, it's going to be where my center, what we call the axis of symmetry, basically. But this is also your x coordinate of the vertex. So for example, this is at -6, that's at +4, so this is at -1. That's like your x value of the vertex, because no matter where you go on this line, it will always be where x equals -1. So that means your h value is at -1. And if you were to plug in h as -1 into this function, what are you going to get? Are you going to get an x -1, or are you going to get x +1? The answer to that is obviously x +1, because -1, and then there's another negative sign here, double negatives, makes it a positive. Okay? And so then how would I be able to solve for this value, which we're going to call k? Well, the k value is your y value for the vertex, right? So if it's a y value, just plug in the x equals -1 into your original function and just get your y value. And it's going to turn out to be -25. Okay? All right, so last picture is, again, didn't I just the very first question I told you was arc length questions, right? So we're going to do the exact same thing. Remember the formula for the arc length? I hope you do. It's this, theta over 360 times 2 pi r. That's your arc length, okay? Just a little food for thought. If you take the same ratio, theta over 360 times pi r squared, which is your area of the circle, it gives you sector area. Okay, what is sector area? Let's say you take a pie of pizza. The area of basically the pizza slice is called the sector area. Okay, so in the figure above, the circle has center O and has a radius of 10. If the length of arc AB is 5 between 5 and 6, so you'd use 5.5. Very good. This is great. What is one possible integer value of x? Now, it doesn't really matter what you use for the value of A to B. You can use it like 5 or 6 or 5.4, 5.135, or all I care. I probably would have used 5.5 as well, because I feel like that's like the safest value to use. And what is one possible integer value of x? Notice the word possible. That basically means that there are going to be multiple answers to this. You literally are given everything you need for this formula. You're going to solve for x, which is your theta, right? So theta over 360, or you can call it x over 360 times 2 pi r, which is 20 pi, is going to give you 5.5. Okay? So let's say that you did that and you solved it. I'm going to use my calculator again. I'm going to do 5.5 times 360, because I need to multiply both sides by 360 to get rid of the 360 here, right? I get 1950, so 20 pi times x gives me 1980, and 1980 divided by 20 pi. I get x to be somewhere around 31.5. So what does that mean? It means that x right now is currently around 31.5, but remember, I want an integer value, right? I want an integer value, which means I can either round up or down. The reason why I can either round up or down is because you picked a number that is exactly in the middle between 5 and 6. So you can either go round up, okay? You can either round up, being closer to 6, and call it 32 degrees. Or you can round it down and call it 31 degrees. It doesn't matter. But I will probably go with 32 because I kind of feel like I should kind of round up when it's 0.5. So the answer is going to be either 31, 30, 32. There are multiple answers to this, but 32 would definitely count as one of the answers there, okay? All right. So I Apple Pencil is almost going to run out, so let me do this the best way I can here, okay? So question number 23 here, right? I don't know if I can still, yes, I can still draw it with my finger. Actually, that's pretty cool. So let's go back. Standard deviation. I know you learned about this from Khan Academy, and plus, if you're hearing up from some other, tutorials. Standard deviation is what I would like to call, how it starts with S? It also starts with S. How spread out the data is. So what does that mean? It means how much variety of points, how much it varies, in the data points and all those things. So how much more spread out in terms of the data gives you a higher standard deviation. It's more spread out. And vice versa, it will give you lower standard deviation if it's, less spread out. Okay, so I'm going to just put this on the side. Okay, I'm going to just put this on the side. And because I need to take these data here. And I'm going to show you what we call a distribution curve. A distribution curve is a very effective way for you to see visually what's happening in terms of the graph and how it's spread out. I'm going to label this as 76, 77, 78, 79, and 80. And what I'm going to do is for 76, I'm going to put let's take a dot. Just count for just one, right? 77, just again one more dot. 78, two dots stacked together. Take a look at 79. I mean, I don't know how many dots there will be, but there will be 14 of these dots, right? And there will be 3. Do you see, if I were to take the top of these dots and then draw this kind of curve, this is what we call a distribution curve. And so the center measurement of this graph will be here, which is obviously at 79. And look how spread out this data is. It's very narrow, right? That's because so many of these data points happen to be at 79 only, and therefore it has less variety. It's less spread out. All the data points is congested onto 79. Versus with city B, 76, 77, 78, 79, 80, if you do the same thing with the dots, 5, 6, and they're going to be 1, 2, 3, 4, and then 2, 3, and then 6. I know the graph might be kind of looking like this way, but even so, in this kind of situation, we always like to draw what we call a data distribution curve, somewhere centered in the center, right? So it's going to be more like this. I know that these two data points are kind of above it, but we always want to have sort of like a hill graph, like this or like this. It has to be somewhere like a hill. It's not going to be something like this or something like that, okay? So this is a distribution curve. Center measurement here, look how spread out the data are. Because there's less congested areas, this has more variety, right? I mean, it's not like I have 14 of the same 79s over and over again. I have just generally fair distribution of all the different kinds of temperatures here. So therefore, what we say is city B will have a higher standard deviation. So city standard deviation temperature, city B is larger. Answer choice B is absolutely true because it is more spread out. Remember, standard deviation, the S stands for spread out. Okay? All right, I think that's going to be it for today. Again, thank you so much for sending me all the emails here. You remember, anytime when you need help, just keep on doing this. I like how all the pictures are now vertical, so I don't have to flip it over again. Okay? All right, thank you, and have a nice day.